So, hello everyone, and welcome to the discussions of the course Research Methodology in Natural Sciences. And today, I don't know, the crowd is a little bit less compared to the other days. So we have also started like I was waiting because of that only. I was expecting some more people to join in, but anyways, we can go ahead and till the time people can join maybe. Okay, I think so. I'm audible and we are at week 4, and I am Udiptya from IIT Madras, the TA for the course, and this week's videos were mostly encompassing like it continued what we were discussing on scientific philosophies. So last time we had gone to, wait, maybe I will turn my video off. Maybe that's the bandwidth will be good. Sorry. So we learned about the scientific philosophy. So last time we were learning about the different how the history of science developed from the times of like primitive materialism, and then we got idealism, the Renaissance period, how it was important, and during what we got to know about the scientific methods. So Galileo Galilei, then Francis Bacon, and René Descartes' methods of scientific methods. So then it was.
Your voice is very low, Updipta.
Oh, okay.
Yeah, no.
It's okay, or should I?
Yeah, now it's okay. Now it's okay.
Yeah, actually I am suffering from some cold. Maybe that's why. But yeah.
No problem.
And then there was the other Newton's and his efforts towards mechanical materialism. So here we will continue from the scientific materialism. Essentially, this we have also discussed in the last time when we were discussing it. We also took some of the parts from this, but essentially as it was discussed in this session also, so we will take it up. But majorly I have put most questions from the second part of it. Like this we have kept, but this time as I thought the other ones we have already discussed, so we will see what this version of what scientists actually do was something that I have kept in mostly on the problem solving sessions. Just to correlate, just to remind what scientific materialism is. So it essentially has a lot on the metaphysical way of thinking, in which we study things assuming that the characters or the properties of it is given fixed without any change. So that was the idea of metaphysical way of thinking. But in real life we know that everything in the material world is going through change and evolution. The cells in our body, the seeds that a tree starts with, everything is going through a change and evolution. It changes its shape, properties, and everything. So totally going on to metaphysical thinking or metaphysical way of thinking is pretty much narrowing our thoughts. So we have to broaden our thoughts, and essentially now the material world, we have seen that metaphysical way of thinking doesn't fit to all of the things. So now this idea is not to study things that are fixed and static, but to see things in change and evolution. That was the idea of scientific materialism. So we had to go from, so essentially there was two kinds of ideas. One was mechanical materialism and scientific materialism. So in mechanical materialism, they considered whole world as a complex piece of machinery, and any piece of machinery keeps working the same way throughout its time. So it shouldn't change. Essentially, that was the idea. There should be no change in the process. Okay. So that's what the idea was, the mechanical materialism. But then the change came to scientific materialism, in which we were studying objects and phenomena in the state of flux. So flux means in the process of development and change. So we tend to see things in a static mode, and that was the idea on mechanical materialism. But when it came to scientific materialism, we saw that the state or the change is something that is there in the material world, and we need to also study those things rather than only considering things as static and fixed. So there was a transition, and essentially where we were thinking that the world is a complex of things. So that transition came, and people were seeing it as a complex of processes, so in which things are continuously changing and coming into being and going out of being. So that was the idea of complex. So that was the idea of scientific materialism. So the change in the way of thinking, that was present here from the transition of mechanical and scientific materialism. So towards a mature kind of way of thinking, that was the part. Then we also discussed about rise and fall of positivism, yeah, where the positivists they refuse to treat anything as real unless it is observable. Whereas there were people who were materialists, who essentially believed that materials can intimately exist independent of our consciousness. So basically, the reality of any concept does not depend on our ability to observe it. So yeah, then we had discussions on how Einstein. It was like when there were some research on different molecules, and how the people like Einstein helped as a positivist, and then we got some the work on Van der Waals, the work on Boltzmann. So such things were so that those things were at that time of positivism, and Einstein was one of the pillar there. So I think we had discussed all these things at that time. Okay. So coming to the part of what scientists actually do is, you have any questions?
So the question is that whether the Einstein was a positivist or believe in positivist or positivism or what?
Didn't get it clearly actually. Hello? Yeah.
Yeah. The question is that whether he was he believed in positivism or whether he was positivist type of his thinking or scientific believe in scientific.
Okay. Yeah, he was a positivist in a sense, because uh, actually he was he was a kind of a materialist. Sorry.
Yeah, because he was
So
that
yeah.
blank.
Hmm.
He was not.
Sorry.
Uh,
Yeah. Thanks for correcting. Yeah.
that was a question in the MCQ,
Hmm.
and that was a tricky
True.
question.
Yeah. So he
Yeah,
was
that's why I wanted to.
he was a in a sense materialist who believed, and that's how he people were confused
Because
about.
he believe in the scientific, I mean, the experimental theories and all that, no?
So people were, yeah, so he had done all the experiments on how
Yeah,
these molecules exist. So
yeah, yeah.
essentially, yeah.
Positivism say that whatever is observable, that is real,
Mm,
and that you cannot imagine. Whatever you have observed, just stop it first. Don't think beyond that. So that was the approach of the positivism.
true, true, true. Yeah, thanks for that.
Fine.
So, so coming to the second part of the videos, we saw that we also discussed on what scientists actually do. So, as we are scientists, so these lists can, as we are maybe young scientists or starting to be a scientist, so this list goes on and depends really, and this there's something that people common scientists do, but essentially this list is something that can also roll down to something else also. So this can be quite personalized also, but essentially these are some of the things that a scientist usually does, forming scientific questions. So scientific questions is one of the first starting step of us as a scientist, and then we have something called as proposing and testing hypothesis. So hypothesis, what is hypothesis? Making hypothesis and testing it is one of the important parts. Then we have proposing postulates. So yeah, like this may not be a people in modern science they do or not, but yeah, that's also a part that scientists actually do. Then we have something called as measuring the value of a parameter or a constant. That also has lot of examples in the current scientific world. Establishing a function relationship. So yeah, this is something that essentially I think a lot of you who has joined this session also might have felt that they have done. Okay, developing a function relationship, developing a mathematical model. So it's kind of like the next step of developing a function relationship. So people usually go for a developing a mathematical model, and seeking something new by observation or experiment. So it's something kind of a rare, or really people needs to be kind of a lucky also to get and seek something new. And essentially we as scientists uh, usually know the outcome of what we are doing, rather than seeking something new. So seeking something new is something essentially very rare in the current arena of modern science. So coming to scientific questions, so questions can be, so how I try to discuss that how questions can be, and what is the scientific and the unscientific, what are scientific and unscientific questions. So in which scientific questions usually means it follows some certain well defined procedures for getting the questions, and essentially unscientifics are those are too vague and too general. So you need to be kind of specific to your specific to the idea of questions you need to answer. So we can't go and answer such very vague kind of questions. Then questions has to be based on some pre-existing knowledge. So we have plethora of knowledge around us, and essentially those questions should have a base of knowledge, and upon that we would have to essentially design our questions accordingly, and such that so the books we read, the journals we have, the other source material, maybe the wisdom of our research guides are something that essentially form a base for the pre-existing knowledge. Whereas the uninformed questions are something that just those do not have any base. So such questions are considered to be unscientific. If so, essentially some questions can be uninformed, but essentially those, if you find it and you have a base, so it can basically transform to a scientific question. uh, then we have questions based on material process. Now we know about materialistic and non-materialistic ideas here. So essentially some ideas that are questions that are based on material processes and phenomena, whereas unscientific ideas are questions based on personal beliefs, like whether ghosts are real or not. So people can have their own personal beliefs regarding this, and that's why it has a unscientific overview over pertaining to that kind of questions. So yeah, then we have scientific questions in terms of the closed and the open questions. So closed questions are such that uh, closed questions that essentially answers the so any closed question has a basically if you get the answer, the questions closes, and if it is already known, then you can look it up in the literature. Maybe the value of g, yeah, the gravitational acceleration. So such values are known. It is 9.8 by meter per second square. So such things are known, already known, and those are closed questions. So just ask what is the specific gravity of water. So that is something that is known. Or tan theta, tan 60 is what, like that. And then there are open questions. So there are like multiple. So open questions are relatively more complex, and essentially has if you close one part of it, then there remains another part that essentially goes on. So understanding or closing, like getting the matter closed, is something that is very difficult in open questions, and these open questions are essentially formed by many closed questions. So that's what the idea is behind an open question. uh, like uh, like we have so many questions. Yeah, is why is the sky blue? And there are like plethora of ideas beyond it, and plethora of theories and experiments that go on and to explain the things behind it. So those are kind of open questions, and people all over the world is researching mostly on the open questions. Okay. So then we have something called as hypothesis and postulates. So uh, so proposing hypothesis is often the main line of attack for addressing the scientific questions. So we will also see how these are there. So I have essentially kept the slide very dry, essentially because I would be discussing we would be discussing more on the question side of it. And then the postulates are scientific guesses of how the nature works. So let's keep it like that, and we will get and discuss it in detail, maybe in the problem sessions. Then there are other functions that essentially a scientist actually does. So measuring the value of a parameter. So that we told, yeah. So we have to. So there are some constants that essentially was discovered or determined by some individual, some scientist. So that is one of the important thing. Establishing a functional relationship. So we already have, yeah, we have independent variable x and y variable. So maybe you must have done some experiments like some for example yeah. So take an example of a sugar syrup. Okay. Sugar solution. So you can take a relation between the concentration of sugar. So here it is concentration of sugar, and here the density of the solution. Okay. So when you put more sugar, the density of the solution should increase. So there we can have density of solution. Then we have some concepts of refractive index. So yeah. So this can vary. So those are some relations that you can develop through this. And then we have, so this is kind of a trend, yeah. This trend is something that is a relationship, and we have different kind of dependence, yeah. Like y equal to this, maybe y equal to mx is something, this straight lines are. Then we have y equal to uh, ax y or something, x ax comma some different variables. This is called as power law dependence. So those relationships can also be established. Then we have some mathematical models. So nowadays, with the power of computation and uh, AI and all this ML, so developing mathematical model is one of the most like sought upon areas. So people are establishing some causal connections to the different processes that are occurring within the system. So that is making it more easier to understand the different factors or parameters involved in a process. And then we talked about something new that essentially, like for example, Leeuwenhoek, when he first discovered the microscope, he observed the microorganisms. Yeah, before that we couldn't and like it was, the idea of microorganism was something that was very primitive to us. Then we had, after this, then we could observe this distant stars and far galaxies after we had uh, advanced telescopes and all. Yeah. So yeah, like what we were last discussing before that. Uh, Now the research is on, like, now this kind of research is like, let us see what happens. Yeah. But mostly we have research in which we know it will happen. So that's the shift, like before it was. And then that's why the rate that people are doing the revolutionary science, or such kind of paradigm shifts that we were discussing in the last section, are quite lesser, like compared to the like the times that were there where we were getting so much kind of this revolutions. So kind of it is also important, like we discussed about the closed questions and open questions. So it is also very important, as a students like us, it is very important that we get to know about uh, the basically we have. So one idea is, like, we can, like as we discussed, how this open question is kind of consists of a lot of closed questions. Yeah. So we as students doesn't know, in sometimes in some cases we don't know what is, so essentially we can be given a smaller closed question, and essentially we have to work upon that. But as a student, as a scientist, basically we also need to understand what essentially is the purpose of this closed question, and how it contributes to understand the bigger question in mind. Essentially we sometimes get focused on a smaller thing, or we get very narrowed upon, and essentially that essentially is kind of gives us a improper idea of our research. So we need to expand it. Essentially that's how we will develop, and others will also be benefiting. So coming to the problem discussions, okay, there are evolutionary and evolutionary developments in science, the later marked by paradigm shifts. The idea was proposed by
Thomas Kuhn. D.
others also. So you all can maybe answer in the chat, or also discuss. Somebody I think has unmuted. Okay, now I think it's okay. So can anybody tell what was the basically idea beyond it, behind the thing?
When there is a particular way of thinking and then the way of thinking changes, it's called as a paradigm shift.
Mm-hmm. Okay. So he also told something uh, on puzzle solving modes of thinking. So he had essentially told that these paradigm shifts, these times of paradigm shifts, he had referred as puzzle solving. Puzzle solving mode, kind of. So people are essentially uh, so basically the parts that are there with the only the observations, they are essentially developing the science that essentially addresses those puzzles and make it more complete. uh, so that's what. And he also essentially also told about the evolutionary parts, when which he told that science goes through this progresses like progresses not on a uniform not on a uniform pace, but has sometimes so pace. And when this pace accelerates is where uh, is we have some revolutionary uh, phases. So that's what he told about the different parts. So the idea is Thomas Kuhn. Can anybody tell what is disciplinary matrix? Okay. So I think you got the question, yeah. So So classical physics with Newtonian mechanics and Maxwell's electromagnetism as basis constituted such a disciplinary matrix, and the development of quantum mechanics was a. So this is a kind of a fill in the blanks and. So yeah, first if anybody has any idea with disciplinary matrix, they can put forward it, and then maybe we can go on discussing the questions. Some guesses would also work, no issue with that. So nobody, disciplinary matrix. Okay. Yeah, somebody wants to try? No. So essentially, it's kind of a framework, yeah, like kind of. Yeah. It's basically a framework which the scientist essentially uses to conduct their research. So essentially, it's kind of like theoretical or methodological framework that the scientist will have, and essentially will design their experiments or conduct their research accordingly to that principles or that framework. So it's that's what it is called as a disciplinary matrix.
What is the answer of this?
So yeah, so essentially the answer is paradigm shift. So uh, essentially its paradigm shift is because before this, like why is it a paradigm shift? As we discussed, paradigm shifts are those revolutionary phases, and where essentially we have new forms of science developed. uh, Here we had a disciplinary matrix in which people were trying to explain all the phenomena or all the processes that is happening in like in a physical world using the classical physics of Newtonian mechanics and Maxwell's electromagnetism. So, but there were some things that were not explainable with such laws of Newton, and then then developed the idea of quantum mechanics, which essentially was a paradigm shift. And that's how we had a different branch of science, a different branch of science or physics particularly, which essentially that's why we told is a paradigm shift. So this was also idea of Thomas Kuhn only. Like analytical shift. Okay, what was the thing I missed? So it's a paradigm shift. It's a paradigm shift. Yeah. So I hope you got the idea. Okay, we'll go to the next one then. So, which of the following best describes a hypothesis?
An unproven statement that can be tested.
Okay. Let others also wait till others also involve. Okay. Yeah. Kind of straightforward. Yeah. So maybe going to this one, can anybody tell what is hypothesis?
Hypothesis is actually an assumption which has to be tested. So, um, so it's an unproven statement, but whether it is null or something which can happen or something which is not happen. So that's hypothesis.
Okay. Maybe
A
somebody else.
statement which shows a cause-effect relationship. A
Okay.
null hypothesis, no relationship, and alternative is sorry, yeah, alternative there is a relationship.
Okay, that's the normal hypothesis maybe first. Then we can go to the the other classifications maybe. Like simply kind of what is hypothesis?
It's an assumption.
Yeah. Okay. So yeah.
Hypothesis where it is less evidences, only few points are there, on the basis of which we can test it and we can say it's
True. True.
we
True.
can
Yeah.
decide on that.
Yeah. So hypothesis, like to summarize everything, is kind of a uh, maybe scientific guess or a intelligent guess maybe that we think our system is going through regarding our system. So and then essentially we have the different testing methods to essentially test it.
So it's like a problem, and then we have to find a solution to that problem by making some experiments, and that is to be tested. The
Testing, yeah.
solution and the solution can be found out by way of the experiment
Yeah.
to prove
So
or disprove that hypothesis.
yeah, so that testing method is what is called as a method of science.
Yeah, yeah,
So we would tell it as a method of science.
yeah.
So yeah.
Fine.
In some places though it is there are lots of method, but essentially I think as per some sources it is that's what method of science is.
Sir, I have a question.
Yeah, please.
Sir, is hypothesis same as postulate and or it is different?
Okay, maybe we will wait till the last question maybe.
Okay, okay.
Sure.
Sir, this is for week 3 or week 4?
Week
This
4.
problem?
Week
Week
4.
4. All right. All right. All right. Thanks.
Then we have this question. Uh, so these are square. Look, okay, I couldn't put it like these are powers. So there are some examples given, and we have to tell whether those are postulates. Which one of them is a postulate? Okay. Yeah. Uh, why A maybe?
Because it's a basic fact so that the triangle can be formed. Sum of all angles in a triangle is 180 degrees.
Okay,
So
but
all
yeah.
options, Pythagorean theorem, and all these theorems are proven by based on some other postulates or other properties. So that is my just thought from my end.
Yeah, nice. Anybody else also wants to add something?
Answer A, because that is a postulate and that is to be proven.
Okay. As in?
That is proven that they have they have a 180 angle is 180.
Yeah, others are also proven, kind of.
Yes, others are proven, but this is not actually this hypothesis is not the correct one. No? That may be a false one. So that we have to prove.
Okay.
It is
Yeah.
what I think the passability that based on the passability creation.
Yeah, essentially it is something that is taken as truth, and
Yeah.
essentially the other things are also developed depending and considering that as a truth. So that's what postulate is. So essentially the A should be the correct answer.
So, difference between the hypothesis and the postulate, what Tejal has asked. So,
So
it
yeah, like we have a question on it, so maybe that's we keep the suspense till then. Maybe.
okay, fine.
Yeah.
I think it is one and the same. It is one and the same. There is no
Okay.
much difference. That is to be
So
tested. That all.
yeah. So what is the purpose of a hypothesis in a scientific research? Okay. So why not the other options? So so people are only telling about B A. Okay, B A. Okay. Yeah. So can anybody unmute and tell?
These hypotheses basically first option to prove a statement.
Okay.
It's not a statement. What I feel is it's something like an assumption which has to be proven. Okay.
Mm-hmm.
So to make an educated guess about an observation, B can be an option. C, to provide a final conclusion. No, hypotheses are not made for proving a final conclusion. Hypotheses are first a guess, a scientific guess, as you said.
Mm-hmm.
So to support a previous conclusion, that also won't be a right this one, because uh, uh, we are assuming something. So based on, it's a scientific guess, so definitely no previous thing will come in this picture.
But you can have previous conclusions.
To support a previous conclusion.
Mm-hmm. Mm-hmm. Like yeah, like you have a hypothesis, yeah, uh,
Mm-hmm.
like we have so something like you decide, you make a hypothesis, like I have a bag of cotton and like a stone which will fall faster. So you have your hypothesis and previous conclusion that gravity is there and all these things, and then you decide, you make a hypothesis that okay, the maybe the stone will fall uh,
Then B and D will be the options.
Okay, essentially this is a single correct anyway, just for discussion's sake I am just
It is
making it,
no,
but
but that also can be an
mhm.
option. See, where you are saying support a previous conclusion.
Yeah,
See, in a
just
way,
yeah.
in a way, if we look at it on a
Mm.
rough basis, then
Mm.
everything can be an option. Like to prove a statement, like that can be also an option to make a
Yeah.
educated guess. Yet to provide a definitely hypotheses are first formulated to derive at something as a at a final conclusion to test and then derive at it.
Yeah, but
So
so we are
that
looking here for the main
purpose,
purpose. Main
the main
purpose.
purpose. So to make an educated guess about an observation, this will be the right one
Yeah.
as per me.
Yeah, that's the correct one. The other ones are like kind of subsidiary, or that like to prove a statement. It essentially we as scientists can't presume things. Yeah, we that we will prove a statement and or not. So essentially, it's just a guess. We will see if the guess works. It works. It doesn't work. It doesn't work. So and uh, we have final conclusion. Sometimes the questions are open, so it doesn't conclude anything. In science, there are very less final conclusions that can be made to support a previous conclusion. So yeah, some test statements we can have in a scientific research, but those essentially are not common. Like those can be a part, but yeah, open questions or closed questions or previous conclusion, or it's not always that we support a previous conclusion and make.
I agree to the one like when we say what is a purpose, the word purpose is there, no? That is
Mm-hmm.
why other
Hmm.
sentence becomes invalid
Hmm.
because the main purpose of it is to
Yeah,
make the educated
educated
guess
guess.
about an observation. Okay.
Yes. Mhm. So I think everyone is uh, agreeing to the thing, and then we can go to the next one.
Yes.
So yeah, then it came to null hypothesis. So you all were that time I had objected. Okay, don't tell. Maybe it will reveal the answer. So yeah. So which of the following is an example of null hypothesis? So we have some cases, and we have to tell which one. Okay, so yeah, can
First
anybody?
option, A.
Okay, okay. So, so yeah, first maybe I will maybe we can why A. It's and then we can ask somebody why it's B maybe. Somebody in favor of A, speak up. Okay, then B maybe.
There is no significant difference between the two groups. Why? Because null hypothesis itself, the characteristics, it shows that there is no relation or significance between both the variables. That is what is my understanding.
Okay, anybody would like to add anything?
No, I agree the same.
Yeah. So I think I have a kind of big explanation. So the problem is asking about null hypothesis. So in statistics, I think so. So statistics is important. Like we have this course as a part of kind of like important or must do course for research. So statistics is another one that is important for us as researchers. So in statistics, the null hypothesis is a statement that assumes there is no significant relationship or difference between two variables being studied. So So there's example that if we are comparing the effectiveness of two different drugs, the null hypothesis would be there. There should be no significant difference between the two drugs. The alternative hypothesis on the other end would be that there is significant difference between the two drugs. So the purpose of testing the null hypothesis is to determine if there is enough evidence to reject it in favor of the alternative hypothesis. So here, that's why the answer is there is significant difference between two drugs. So anyway, yeah, the one argument that you gave is kind of explained everyone. So we'll go to the next one then. So which of the following is a characteristic of a good hypothesis?
C is the answer.
Okay. Okay, yeah. So as we have discussed, it is testable and falsifiable. So can anybody tell what is falsifiable? So actually I just added it in a sense to discuss something out of it, because it
So
essentially
which can be testable, which is true or false. That can be made it false. So that is what from my end. That's what my
yeah.
thought.
So essentially I think it is not discussed in this videos, but I think we will face it in the next one. So yeah, anybody would like to add anything on that?
Assuming the hypothesis is false.
Okay. So yeah, so anything essentially is Einstein had a famous saying that that no amount of experiment can ever prove me right, and a single experiment can prove me wrong. So essentially that essentially tells us how the statement is. I think yeah, just
That the she said that single experiment may
so
invalidate.
yeah, so it's like no amount of
100 experiment may validate, but
I don't
101
remember.
yeah, exactly, that is what that 101 experiment may invalidate the type.
Yeah, prove me right, and
Prove me right, yeah.
one experiment can get me wrong.
But that does not mean that those 100 experiments they were wrong. Yeah, it's like that.
Yeah,
They
so
were also
maybe
true, but that
yeah.
101 was made under the circumstances and the phenomena and conditions.
So yeah, maybe we are not going in detail on that, maybe because next week maybe it is there, but just a thing, that I wanted to discuss. So yeah, should be testable and hypothesis falsifiable. So yeah, essentially we discussed the things that should be testable and falsifiable, and also I gave a kind of because I didn't give it there, so I thought I should include it here. Yeah, so yeah.
So, can you please explain the exact, I mean, in a simple manner, the meaning of this falsifiability? Because that word itself creates a lot of confusion. Now, although it is easy to understand, but then in simple term, how can you define this?
So it's like we take every theory with a pinch of salt. It can
Yeah.
be false. That's a simple maybe. Everything can be true or false, and yeah, that's the thing.
Yeah,
We have to take
that
it
is
with a
good.
pinch of salt.
Yeah, thank you. Fine.
So yeah, it discusses but to make predictions are coming in and incorrect because of a good hypothesis would be vague and preconceived notions. So yeah, so that's that. Anyway, if you we can always come back. This PPTs are always there in the drive and always accessible to you. So you all can come and maybe see to it again if you are want to recall these things. So yeah, so what is positivism? And we discussed something about what positivistic thinking is and how these things are. So essentially. Yeah, can anybody tell what is this difference between this subjective experience and empirical evidence?
Subjective experience is something that you're assuming based on facts, but
Mm-hmm.
empirical is based on the observation and the experimental data.
Is it?
Subjective, subjective is nothing but it's a personal belief,
Mm.
personal observation, and empirical means whatever observable, that is real by way of your observations, like that.
Then what is objective evidence then?
Objective is that what you see, the object, the material you see, you can have a sensation, you can have a touch,
Mm-hmm.
you can see physical
Uh,
existence.
yeah,
No,
like what?
subjective experience, not subjective observation. It's subjective experience is different, no, from observation.
Mm.
That is what they define positivism means. That is what is observable. That is the real thing. Because beyond that observation, you cannot think of it. That is exactly the story. I mean, scientific materialism.
Okay.
So they say that whatever we observe, that is true, and one cannot see beyond that. One cannot see beyond that.
Mm-hmm.
Then it will be
That
empirical.
means whatever organisms or whatever we see in the universe, that is true. Now there are
Mm-hmm.
the microorganisms that can be seen through the microscope. So you
Okay.
cannot think beyond that.
Mm-hmm.
There may be microorganisms that we don't know, but they say that you can't see. Don't believe that. Whatever you observe, that is the real. That is what the in simple manner it is. I can define that.
Okay. Somebody would like to add. I think they were telling. Yeah. Would like to add. You're telling something. Somebody would. No, no. Okay. So essentially, coming to the answer, it is a philosophical approach that emphasizes the importance of empirical evidence. So we also discussed something about the empiricism time and uh, so essentially here to summarize, it is based on the scientific ideas based on the source, basically based on experiences. So whatever a person experiences, it essentially those are the source of ideas, and it's not a subjective experience. Essentially, because it is not a subjective experience, because those experiences are common with, so they validate with the other subjectives also. So that's how it becomes an objective experience. So that's how they developed this, and essentially the philosophical approach that involves this is empirical evidence, because only things that we can experience, the positivists believe that. The other things that is beyond our experience is something that a positivist doesn't believe in. Essentially, that's what was the idea of it. I hope I made some sense here. So yeah, so we were also discussing what is the example of what is the difference between the objective and empirical, objective evidence or empirical evidence. So okay, maybe maybe you can think upon it, and we can discuss it the next time maybe. But it's a nice outlook at how things are. I'm also not much clear, but yeah, if somebody can discuss, maybe we can add those things. So how these two things can differ, the empirical evidence and objective evidence, because there is a kind of, the ideas are quite closely related, but usually it has a thin line between them, and that separates both of this. Okay, we'll go to the next
Something
one.
measurable.
Uh, so empirical, so measurable in a sense of what, objective or empirical? So what is a measurable term? Yeah, empirical. Essentially, yeah, empirical evidence is something. So it's like, if I give an example, it's like, let me think about something. It's like we have a photograph of an event. Okay, so that forms a base for objective evidence. But essentially, if it can't be repeated, or it can't be replicated in the same conditions, then we can't take it as an empirical evidence. So it's like all empirical evidences, I think all empirical evidence are objective evidence, but all objective evidence are not empirical evidence. Let me write it down. I also not.
No,
So
actually,
please,
yeah,
please, yeah.
I couldn't get the difference between empirical and objective. What do you
It's
mean
like
by empirical, and what do you mean? See, objective is based on the observation and the
observation.
data.
Mm-hmm.
Yeah. And
Yeah,
empirical means what you said earlier is mostly based on the
experiences.
experiences. So they both are completely different, right?
True, true. So as we were talking about, so there it was. So here we were discussing about what is the difference between empirical evidence and objective evidence. So that's how we were. I am also not clear much, but yeah, but there lies a slight difference between both these things actually. And yeah.
So, like in sociology and all that, no? In sociology, psychology, we do observation, certain observation, but it is
Mm-hmm.
not. Some things may not be measurable. Once it is, if you're talking about empirical, it should
Mm-hmm.
be measurable. You should have some numerical value.
True. Yeah.
That
True,
is
true.
the. If it does not
Completely.
have numerical value,
Mm-hmm.
then that's a difference.
Yeah. Plus with
That is that will be taken in terms of the quantity. Yeah, what I mean.
quantity. Yeah. Yeah. So
Measurable
something.
because the quantity is measurable, so that why
Mm-hmm.
we consider data, and sometimes we take it as a quantity.
True. Yeah. So empirical must have some measurements involved in it. Measurements
So there
like
are two empirical
systematic. Mm.
quality and quantity. We consider in empirical data we consider quality and quantity.
Hmm. Yeah. So
Like
yeah,
height,
maybe yeah.
Definitely that can be measurable.
yeah,
Yeah.
quantity is measurable. That's what.
Yeah. So yeah, like I am also not aware much of it, but yeah, that's something maybe you all can see. Maybe I can also. I will also see what I said. So yeah, moving ahead.
Uh,
Yeah,
we have
please.
that. We have that in our research with research. We are doing our research. There is a
Yeah.
doctrinal and non-doctrinal. They're based on the empirical data and the non-empirical data. So that two sorts of conditions are there. How we
Okay.
conduct our research.
Yeah. Okay. Yeah. So yeah, the concepts of scientific materialism. Yeah, the world is a machine, and everything should go as written or as the law has told. So that's what is a scientific materialism. So yeah, the last question that I was telling. What is the difference between axioms? So axiom is something that we didn't discuss in the video, uh, but there are some common terms like yeah, you may come across something called as axiom, hypothesis, postulates, or maybe you can also include a theory and laws. So, if anybody has other terms, they can also add. We can discuss maybe. Yeah, because this is the last
Example
question.
and postulates, they are one and the same thing.
Okay.
What we call as synonyms of postulates.
So maybe we can start with the definitions maybe.
Axioms are
Yeah.
universally accepted.
Okay. So you have any examples?
We usually say universal truths.
Mm-hmm.
Scientific guess.
Uh, uh, so it is quite general maybe I think. Then it becomes very general. So I don't remember, but I think in class 7 or 8 we learned something about Euclidean axioms. I think so. I don't remember much, but yeah.
I think postulates and axioms
Uh,
are the one
uh,
which are facts
Okay.
which may not be false,
Mm.
because then that those are all are proved already, and those became a facts. And hypothesis is the process which we will try to think it is not it is false first, and later we will make it true, just to prove. This is the process of a hypothesis, just a process.
Mm.
Axioms and postulates are, I think, one and the same. These two.
Okay.
That's
Okay.
what from my end.
Mm. Yeah, like so we had actually learned all these things in preliminary things, preliminary classes, maybe just about how there are. One example is the Euclidean axioms. So Euclidean had given 5 axioms. I don't know if uh, uh, like they like the axioms are quite interesting. Like things which are equal to the same thing are equal to the other, and it was like that. If equals are added to equals, the wholes are equals, and if equals are subtracted from equals, the remainders are equals. Then things which coincide with one another are equal to one another, and the whole is greater than the part. So these are the 5 axioms that Euclid had given. So so essentially axioms are postulates that we were talking. So essentially axioms are some statements that are assumed to be true, and without any proof. So we do not have proof for axiom. Those are taken without a proof. And the slight difference that axioms and postulates will have is axioms are quite general, very general, and postulates are something that is postulates are something that is very particular and involves very particular field of studies. So that's the difference that both these times have. So can anybody tell about postulates or give an example of postulates?
Postulates are used in geometry, like
Mm-hmm.
we an example.
Mm.
Sum of angles of a triangle is 180 degrees. So
Mm-hmm.
it's mostly used in geometry, and axioms are used in all the mathematics like
Yeah. So yeah,
algebra and all.
just that's what I told. So axiom is
It's derived from a theory, postulates. Postulates are
okay.
derived from a theory.
Like what kind of theory? Can you give an example and tell? What is assumed to be true?
Axioms and postulates are nearly
Uh-huh. Yeah.
axioms are nearly the true, all facts, because based on that we will try to prove some other rules or formulae or equations or anything, because we assumed all these are facts, all
Mm-hmm.
these are, so the basic things, the logics are uh, to which we cannot prove. So the basic one, so those are can be axioms and postulates.
Mm. Yeah, essentially both are same. Like in a sense, the meaning is same, but the difference comes in the area of application. Axioms is something that is very general.
Yes.
Like apart from maths, you can actually use them in life, maybe like your normal physical things. But essentially,
Yes.
postulates are something that are very specific. So if I recall some example of postulates, like we discussed about the geometry one, that was one of the example. uh, some other examples, we have this, the line grows infinitely. Yeah, so it can grow infinitely. So then all right angles are equivalent.
Yeah.
Yeah, all right angles are equivalent. So those are another one, maybe uh, like through any 2 points we'll have exactly one line. So these are postulates. So we can have, mostly these postulates are of geometry only. I don't know any other use case maybe, but yeah, if anybody has any they can add. I can't maybe. So these are what postulates are. So next we go for hypothesis. Yeah, hypothesis is something that we have mostly discussed. So can anybody tell what, just to write here? So as I told, a scientific guess. And then theories. Theory and law. Okay, essentially these are something that we haven't discussed actually, so yeah, that may not come naturally. Just we add it because it sounded, it is something that we encounter. Anybody would like to just guess? Guesses are also welcome here. No issue with that.
A theory which is proved becomes a law.
Okay. Theory which is proved becomes a law.
Becomes a law.
Okay. So theory of relativity is not proved, maybe, yeah.
A theory can be proved with a proper explanation, then that is a theory.
I didn't get it. Theory can be
a theory which has a proper explanation, proper proof, then that can be a theory. And the law can be the process of making the proof. So based on the variables or comparisons or corrections, simplification, the statements. So that can be, based on that can be a scientific law.
Okay, more simplified, maybe somebody.
Theories can be proved only on the basis of the experiment.
Okay.
That is what I feel in a simple manner.
Okay, yeah, and law?
Hypothesis is a scientific statement based on the theoretical evidences, earlier theoretical evidences, which can be subjected to the causal relationship.
True, yeah.
Which may be right or may not be right.
Yeah, so yeah, correct, yeah. But yeah, so essentially we're talking about theory and laws.
Law is nothing but they are the rules, and they are framed after observing the things, because without observation we cannot make the rules, and without the rules we cannot make the law.
Okay. Yeah, so essentially, if we find so theory and law. So you are saying a theory has measurements involved, but law is something that has observations or experiences involved.
Yeah,
Yeah.
but that, because in order to frame the law, you have to first frame the rules, and the rules are
Mm-hmm.
based on the observations.
Mm-hmm.
So without the observation, how can you make the rules?
Yeah.
Then the rules ultimately leads to the making of the enactment of the
Yeah.
laws.
Essentially, this is a body of knowledge.
Yeah, the body of knowledge that based on the experience and the observation.
Yeah. And
We suggest why something is happening, means why it is happening. So we give a theory. And
hmm,
for law, it's the how it is happening. So we give
true.
a detailed, like mathematical explanation
Yeah.
why it is happening. So theories for how it is happening, sorry, why it is happening, and law is for how it is happening, I think.
Yeah. Quite. Yeah. That was, I think. Yeah. Kind of simplistic and quite. So it draws a fundamental relationship. So, like essentially that helps us predict also the future outcomes of the system. So that's what law is. So theory is a body of knowledge, whereas law is law is what gives the fundamental relationships between the patterns in the nature, which are essentially based on the repeated observance or repeated experiences. So that's what is the thing. So yeah, and this list goes on. Yeah, we might have missed a lot of things. There are a lot of other similarly sounding things also, and essentially just uh, yeah, those are some of the things. Essentially, I went. We also discussed something that is out of the syllabus, but yeah, that's what it is. Okay. Yeah. So essentially, today's session was still that only. I think today's
Sir,
session
can you
was.
please?
Yeah. Please.
So can you please repeat this postulate talk?
Oh yeah. Sure. So yeah, the difference between axioms and postulates is quite a thin line essentially. Because axioms essentially mean that these are some statements that are assumed to be true without any proof. So, but the thing is, axioms are very general. So, just I told you, just search about it. I don't remember exactly the statements also, but like you can search about the Euclidean axioms. Euclid had given 5 axioms, and essentially that's how. And you will see those axioms are like I had already mentioned. Those are very general. Those are not like it's not applicable only to maths or such things, but also goes down to other areas of science also, or maybe of physical human living. But postulates are something that are very that basically is a specific thing and specific idea about an area of study, and that's how we have postulates. We have a lot of postulates about geometry. Geometry will have a lot of postulates about line, about a line segment, a circle. Like you have all the points equidistant from the center of the circle. So those are postulates. Okay. So that's what is the difference between all these things. So if I had to give a kind of proper or kind of a bookish answer, so essentially these are postulates are scientific guesses about how the nature works. Yeah, that's what it is. So it's like explaining something that has happened in the nature. So yeah, like we will listen all about the this no the absorption and the emission of radiation matter. So we postulated that okay, the the electrons will have the different energy states, and they jump on these energy states, and that's how we get emission of light or absorption of light. So those ideas were something that are such postulates. Those are very difficult to experiment or very difficult to prove. Some prove like just some knowledges are just like they are taken as it is, and all the research is based on those things. So it's the idea of it. So yeah, like so the main purpose of so one can ask, what is the main purpose of a postulate? So the main purpose is the predictive power. So it is one of the important things. Like if anybody proposes a postulate, the one thing it should do is it should predict the experience, predict the experiments out of it. The postulate shouldn't fail with the then it becomes a postulate basically, because it forms the basis of the test. The predictive power is one of the important thing of a postulate. So essentially, because you are only relying on it, treating it as a truth and relying all your experiments on it, so its predictive power should be high. That's what is a postulate. That's what make an ideal postulate. Yeah. So it forms a predictive power should be high, and it forms a base for test. Yeah. I think I made sense here. You would like to discuss something on this? Okay. Yeah. So yeah, essentially, if you have any other queries, we can take. So no more queries. Essentially, I think the Sunday session, I think because I am leaving for a research visit to Norway, essentially because of my some research. Essentially, I think that the Sunday session will be discontinued from NPTEL, like the session I am taking. I'm not sure, but essentially the mail would come from NPTEL only. So essentially this would be the last session, maybe I think so, from my side, and so, yeah. Yeah, so the message will come from the NPTEL itself. So yeah, that's the thing. Thanks. Yeah. So it's so you all can reach out to me. It's always fine. I will just maybe put my this is my mail ID. You all can reach out to me if you have any doubts about the course. I will try to address it, and yeah. Thank you all for joining on a Sunday. It's always difficult. So yeah, if anybody has any questions, they can stay back, or otherwise people are free to leave. And yeah, that's all. Thank you. So some people had issues with the course. In a sense, I hope it was like people are from now only you discuss that some of you have joined from sociology also. I think now it is making. I hope we are making the things are now making sense, and it is understandable to you. Yeah. Okay. So Abhishek has a question that the characteristic features of a mechanical materialism are that the belief that matter does not exist independent of our consciousness, viewing the world as a law governed requiring no divine intervention, viewing the world as a gigantic machine, the belief that science should be built based on a personal realization. The answer is correct. Score 1 is accepted answers. Viewing the world as a law requiring no divine. Yeah, so yeah, I think so. It now it has, yeah. So anybody would like to answer? Why to Abhishek's? Anybody would like to answer Abhishek's query? Abhishek, you are here, no? So what's essentially the doubt here is, can you clarify, like, where should we discuss it, or maybe you can write also if it is already okay. Abhishek, I hope I am audible to you, yeah? So essentially the term mechanical materialism usually they had like how that's what it was like. They considered everything as a comprising of a part. Like we have a mechanical machine currently, yeah? It has lot of gears, and each gear rotates, then the other gear rotates, and that's how everything works upon. We get a pulley or such things. So essentially that was the belief people had, that there was a set of rules, that's how the machine will work. And because that's why they were essentially the first, this option of viewing the world as a viewing the world as a gigantic machine. So essentially everything should be connected to each other, and the cumulative effect of everything, the addition of everything is what is giving the effect. That was the characteristic feature of mechanical materialism. And the thing is, like a machine, yeah, like the machine will have a common set of rules, common set of movements, degree of movement, or how it moves, how it rotates. So that's what is the law governed, or okay, yeah. So essentially here, being the law governed is something that is telling us that essentially every machine will have we will run on a base of on the basis of a set of rules, yeah, or a set of principles, how like depending on the design mechanism of it. So that's what it is telling. So a machine will go on working, it does not need any divine intervention. Okay, that's what is the idea of this mechanical materialism. Yeah, so everything, like all the biological processes, all the cells should be seen as a machine, and it should go on performing the same function from starting to end. I hope clarified the things. Yeah, if it's not clarified, you can please keep your thoughts. Yeah, Ankita, you wanted to ask something? Okay, yeah, sure. So anyway, the videos will be available, and also the material, all the PPTs that we referred to will be available to all of you through the course page. So yeah, that's all from my side.
Thank you, sir.
Yeah, sure. Okay, if anybody has any other questions, they can ask. Others are free to leave. What is scientific hypothesis? So as I told, so hypothesis is a kind of an intelligent guess or scientific guess. I don't know what is basically a scientific hypothesis. I don't know what it should particularly mean, but essentially a hypothesis is something that is a scientific guess, and essentially every hypothesis will have some form of science, associated with it. So essentially, a scientific hypothesis should be something that relates to a scientific domain. That's what is making sense to me. So it's kind of a guess, but we don't know particularly what is it. Observational facts about the phenomena. See, if it's like, I don't know if it's a part of a assignment or not, but yeah, I don't know. If it's, then I can't essentially discuss. Okay. So okay, then maybe we can close the session here. Okay, then thank you all, and all the best for the rest of the course, and for the exams also. So hopefully we'll do good in this subject. So yeah, thanks a lot, and just write to me if any pertaining questions, and yeah, that was what for today, and yeah, that's all. Thank you.